Hello, Algebra 2 students. This is our review for our Unit 7 Quiz 2. Okay, we're going to expand the expressions. Hit pause, give them a try, see if you can try these out, and then come back to check to see if you got the right answer. Welcome back. So for this first one, it is log base 8 of 2dy. So to expand it, we're going to keep it log base 8. And then when we're multiplying, which is what's going on right here, when we're multiplying with logarithms, what does that mean? Naturally, it means addition. So we have log base 8 of 2 plus log base 8 of d plus log base 8 of y. And that would be your answer to the first one. Second one is log base 3 of m to the 5th. Now remember, whenever we have an exponent with a logarithm, that gets brought out to the front. So this becomes 5 log base 3 of m. And now this next one is going to combine both of those aspects. We have a multiplication and we have an exponent. Now, this also does not have a base listed. So what is that base, or what is the base of the common logarithm? You should know that. Do you remember? Do you remember what it is? That's right. It has a base of 10. So we have, but you don't have to write the 10. The 10 can just be invisible. So we have log of w plus, we're going to bring this 3 out to the front, so 3 log of x. And that would be your answer. We're going to try a couple more expansion problems here. These are a little bit more complicated. So give these a try and come back for the explanation. And welcome back, my wonderful Algebra 2 students. Okay, so in this one, we have a division, we got a multiplication, and we have an exponent involved. Psychoticness going on here. Okay, so we have log base 13. And we're going to deal with the multiplication on top of the fraction first. So we're going to just have the plain old 8 there. And then plus, we're going to bring this 4 out to the front. So we're going to have 4 log base 13 of g. And then division naturally means we're going to subtract now. So then minus log base 13 of x that's on the bottom. And that is our answer there. So the next one is number 5. We have log. Again, there's no base listed, so what base is that? That's right, it's 10. So log base 10 of a to the 3rd over m. So we're going to rewrite it out. So we're going to have, sorry about that. We're going to bring that 3 out in front, so it's 3 log of a. And now again, it's a division, so that means subtraction, minus log of m. And that is your answer. Okay, next one, we have log base 7 of the square root of xy. This one confuses a lot of us in class today. So let's work it out here. We're first going to turn that into a fractional exponent. So that means xy to the 1/2. Because remember back in Unit 6, the last unit, we learned that a square root can also be written as an exponent of 1/2. We're going to distribute out that 1/2. So we have log base 7 of x to the 1/2, y to the 1/2. And now it's a multiplication and exponents. So we're going to bring that 1/2 out in front. So 1/2 log base 7 of x plus 1/2 log base 7 of y. And there you go. So now that we've done some expansion problems, now we're going to go to the condensing problems. We're going to put them back together. We just took them apart. Now we're pushing them back together. So this first one, we have 7 log base 3 of f. So remember that number in front is actually an exponent. So we're going to write it as 1. So log base 3 of f to the 7th, just like that. Number 8 here, again, What do we have here? We have an addition, so we're going to be multiplying some things. And we have a subtraction, so we're going to be dividing some things. So right away, I know we're going to be doing some subtraction, so I'm going to go ahead and set up log and then a fraction sign so I can keep track of what's on top, what's on bottom. Well, we're multiplying the w and the x, so those go on top. Here we're subtracting, so that means, again, dividing, so the y is on the bottom. And there's your answer. This last one, it's an addition. So again, that means multiplication. So we have log base 5. Here we're going to bring this 3 out to be an exponent for this x. So x cubed. And this y is all by itself there. So x cubed y is our answer. Here are a few more condensing problems. Give them a try. Come back and check out the explanation. Welcome back. Here, these are actual numbers in here, so we need to do some actual math and do some calculations. So for this first one, we have log. Again, no base is listed, so that means it's base 10. This is an addition, so that means we're going to multiply the two terms that we're bringing in. So we have a 3, and then we also have, this 2 is an exponent, remember, 4 squared. So that means the log of 3 times 4 squared is 16. So 3 times 16 is 48. So the log of 48. Same type of process here in the middle. We have log base 4. We have a subtraction sign, so that means we're going to be doing some dividing. So I set up my division sign right away. So we bring this exponent out here for the 7, so that means 7 cubed on top. The second term also has an exponent, so that means 2 to the 9th on the bottom. So then we want you to actually figure those out. So we have the log base 4 of 7 cubed, and 7 cubed, you should know, that's one of the ones I had you memorize, or you're supposed to memorize, is 343, and then 2 to the 9th power is 512. And that is your answer. And the last one of the condensing problems, we have 2 addition signs, so that means everything's multiplication. So we have log 5, and then this 2 is an exponent, so we bring it out, so 3 squared, and then this lonesome x all by itself. So we have log of 5, 3 squared is 9 times x, and then 5 times 9 is 45. So log of 45x would be our answer. Okay, this is using your change of base formula. This is all calculator work. Remember, it's the log of the bigger number, so 13 divided by the log of whatever our base is, in this case 7. So log of 13, and then make sure you hit the close parentheses, divided by the log of 7, gives us an answer of 1.32. I'm just sorry, I'm checking the instructions and said round to the nearest thousandths place, so that's tenths, hundredths, thousandths, so 3 decimal places, 318. So the second one here, number 14, is log of 84 over the log of 4. And again, we do this so we can plug these in our calculators. It makes it a nice, easy base 10 that our calculators can handle. So log of 84 divided by the log of 4. And then again, rounding to 3 decimal places gives us an answer of 3.196. And the last one is log of 756 divided by the log of 13. Gives us an answer of 2.584. Now you're going to need to know change of base in order to do the next problems. Okay, so we're going to solve the following equations round to the nearest tenth. So give this one a try. Come back for the explanation in a moment. Okay, welcome back. First thing we want to do here is we want to add 15 to both sides so we can isolate the exponent by itself. So we have 11 to the negative 2x minus 6 equals 17. Now here it's an exponential form. We can't really do anything else here in exponential form, so we need to turn it around and put it in logarithmic form. So in logarithmic form it would be log base 11 of 17 equals the exponent of negative 2x minus 6. Now again, this log base 11 of 17, we really don't know how to do that, so we're going to do the change of base theorem that problems 13, 14, and 15 we're talking about, and that's what we're going to do here. So that's going to be 1.182, and that equals the negative 2x minus 6. And again, we did that by log of 17 divided by the log 11. Now we're going to solve this equation. We're going to add 6 to both sides. So we end up with 7.182 equals negative 2x. Divide both sides, and we get x equals negative 3.6 because the directions say round to the nearest tenth. So that's one place after the decimal point. Okay, another one, 12 to the 3x plus 4 minus 7 equals 13. Give this one a try and come back for the explanation. Welcome back. Okay, to start this one off, we're going to add 7 to both sides. So we have 12 to the 3x plus 4 equals 20. And we're in the same predicament as we were last time. This is an exponential form. We can't go anywhere from here, so we need to turn it in to logarithmic form. So log base 12 of 20 equals the exponent of 3x plus 4. We do the change of base theorem again, and we get 1.206 equals 3x plus 4. And now we solve that equation for x. We're going to subtract 4 to both sides. We end up with negative 2.794 equals 3x. Divide both sides by 3. And x equals, when you round it to the nearest tenth, negative 0.9 as our answer. Yay! One more of these. We have 10 to the x plus 6 equals 38. Now this one's a little different. We're going to subtract 6 to both sides. So we get 10 to the x equals 32. We're going to put this in logarithmic form, but this one has a base of 10 already. So this is that common log we can straight up put in our calculator. So we have the log of 32 equals x. So you just straight up put that in your calculator. Log of 32, rounded to 1/10, is 1.5. And you are done with that one. Okay, these solve the following equations, round to the nearest tenth again. Here, on number 19, we have log base 5 of the quantity 12x minus 11 equals log base 5 of the quantity 3x plus 13. So because they have the same log and same base, that means these parentheses have to be equal to one another. So we have 12x minus 11 equals 3x plus 13, and we're going to solve that equation. So we're going to subtract 3x to both sides. Add 11 to both sides, and we end up with 9x equals 24. We divide both sides by 9, and rounding to 1/10, rounding to the 10th place, sorry about that, gives us the answer of 2.7 as our answer. Okay, and then number 20. Same concept. We have the same log because, again, this is the common log, base 10. So they're the same, so we can set this part of them equal to one another. So we have 8x minus 5 equals 35, and solve that equation. We're going to add 5 to both sides. 8x equals 40. Divide both sides by 8, and x equals 5. Another couple problems completed. Okay, number 21. A lot of you guys had questions on this one in class today. First off, we're going to start off by condensing it, some of the problems we did previously. This is log base 3. A subtraction means division. The 2x on top, 6 on the bottom, equals 2. So we're going to condense the problem first. Now, this is in logarithmic form. It's not doing a lot for us right now, so we're going to turn it into exponential form. So the base is 3, the exponent is 2, and that equals what's next to the log, right here, 2x over 6. And now it's just a matter of solving this equation. 3 squared is 9. I'm going to go ahead and simplify the 2 over 6 and make it 1/3 times x. You can think of this a couple different ways. You can divide both sides by 1/3, or what I do whenever I see a fraction here, I don't want to divide by a fraction. I want to multiply by the reciprocal on both sides. Accomplishes the same thing. So on the right-hand side, we're left with an x. On the left-hand side, 3 times 9 is 27. And that is your answer. Okay, so using that knowledge, let us try number 22. Give it a try and come back for the explanation. Okay, this one, again, it's a subtraction, so we're going to condense it. So log, the base here is 10, because it's not written, so it's a common log. So 20x divided by 7 equals 3. Here in logarithmic form, not doing a lot for us. Can't really mess with it at all, so we're going to turn it into exponential form. So the base is 10, the exponent is 3, and that equals 20x over 7. So 10 to the third power is 1,000 equals 20x over 7. We're going to multiply both sides by 7. So we get 7,000 equals 20x. And now we're going to divide both sides by 20. And we get the glorious answer here of x equals 350. And there you are. You're good to go. Now, all of the next problems, you're going to need to have a graphing calculator with you in order to do these problems. So make sure you have a graphing calculator out. I'm going to go through with you the steps you need to do in order to do this problem. So first, we're going to hit the Stat button. And the Stat button is over by your arrows on your TI calculators. So you're going to hit the Stat button. You're going to hit the Edit button. And then once you get to that point, you're going to start plugging in our points here. I'm going to label them X and Y. We're going to type our X's, go into our L1 columns. Our Y's go into our L2 columns. After you're done typing in all of your numbers, then you're going to hit Stat, and then Calc. And here we want an exponential function. So that means that's number 0 on your Calc menu. So you can scroll down or just hit the 0 button. Either way is fine. And that stands for the EXP REG, which is exponential regression. And that's going to tell us the equation of the line. So you hit all those buttons, and you're going to come up with the answer of y equals 24, and then 1/2 to the x power. Now the same process is going to be the same for all of the following problems. I'm not going to write out this process for all of them, but I will write the answer for each of the following problems. But they're all the same for the exponential ones. Okay, the next exponential function is y equals, this is our answer, so after you've plugged these in and gone through the steps on your graphing calculator, this is what you should get out. Y equals 1/4 times 6 to the x power. There you go. Number 25. This one's going to be slightly different, but only slightly. You're going to go through the same steps of going to the stat edit, entering your x's into your L1s, your y's into your L2 columns. You're going to do stat calc, but this time, instead of hitting the 0, you're going to hit number A, which is usually abbreviated like this, PWR-REG, which is a power regression, and that's going to tell us the equation of this line, which happens to be y equals 0.12 x to the 2.32. Okay, a couple problems left and then we're done. Find an exponential function of the data in the table. Here we're told that the total expenditures in the United States for elementary and secondary schools are shown in the table. That means how much do we spend on elementary and secondary schools. So years since 1997 is our x value, and the total money spent is our y in billions of dollars. So we input this into our stat edit table. Again, your x's are your L1s, your y's are your L2s. Plug them in, go through, and this is an exponential function, so you hit the 0, the exponential function key. You're going to get an answer of y equals 384 times 1.04 to the x power. And then number 27 here says, predict the total expenditures in 2005. Well, our x has to do with our year, so we're going to plug something into x, but do not plug in 2005. We want to find out how many years it's been since then. So 1997 is year 0. Year 1 would be 1998. Year 2 would be 1999, and so on. So what year would it be for 2005? Well, 2005 is going to be year 8. So we're going to take our equation that we just found, and we're going to plug in the 8 and for the x. So we're going to take it to the 8th power. Plug that in your calculator, and you should get approximately, we're dealing with money, so you need a money sign here, is $526 billion. That's a lot of money that we spent on schools in 2005. Okay, the last problems for this review. Here we have rivers and streams carry small particles of sediment downstream. The table shows the diameter x in millimeters of several particles of sediment and the speed y in meters per second of the current needed to carry each particle downstream. So again, you're going to plug these into your stat edit button. Your diameter here is your L1. Your speed is your L2. Plug them in, but this time we're trying to find a power function. So you hit that A button to get the power function. You should end up with the equation. Y equals 0.224 x to the 0.5. That's our equation. Number 29, we'll use that equation to estimate the speed of a current needed to carry a particle with a diameter of 120 millimeters downstream. So we're given that the diameter has 120 millimeters. We see that the diameter is represented by our x value, so that means we're going to plug it into the x. So we have y equals 0.224 x to the 100, it's going in for the x, so 120 to the 0.5 power. You plug that in your calculator and we should end up with 2.45, and we're trying to find, we want to estimate the speed, and that's given to us in meters per second, we're told, in the original problem here. So our answer is 2.45 meters per second. And there you go. That's our review for our quiz for tomorrow, the Unit 7 Quiz 2. So good luck, enjoy, have fun studying, and see you tomorrow.